I hope you didn't see it. But I want to show you how it looked like with the iron filling first. All right, this is the iron filling. This is not pepper. All right, iron filling. You can see this is the magnet. You can see this is a magnet. N is what? And S is south, obviously. And you have to trust me on that because I've tested before. And you can see apparently this is probably from the same manufacturer. And you can see that north will repel and north and south would attract. Yeah. If I try, it will still turn around, and only the S, the south pole, would attract. Same for this. If this is south pole, north will attract, and to the south would repel. Now what I want to do is look at this magnet, and I'll put it here. Okay, and now I will try to pour some iron filling on it and see how it goes. Because you can see there might be some friction, so what I need to do is just to do something like this.
Why does it go together?
Do you see the pattern? Do you see a pattern like the one that you draw? Yeah? This side curve, this side of curve. And how come you can see they kind of merge and concentrate the most at these 2 points?
Because you have a magnet underneath.
Yeah, basically the magnets, the two sides are underneath this side and also this side, and they are attracted to these two positions as well. Because your world is not 2D, it's actually 3D. So vertically, they will also attract towards it. So at least you can now see the pattern. But again, the thing is, this cannot tell you the direction, and that's the issue, right? So that's why we'll need to put this with the compass. You can see, for example, this tray are now showing the direction of what? The north of the Earth itself, right? And they should all point to the same direction. If I try to move them around,
11. Yeah.
oh, maybe somehow. All right, you could, or maybe this box. I think this box has actually. I think this box has some magnet as well. You will see, no matter how I turn it, it will eventually go to the same direction, and that's because of the Earth magnetic, right? But Earth magnetic is actually quite weak, weaker than this magnet, actually. All right, so if you put this close to it, it will change the direction. So what I would do is, right now I've got the magnet, North Pole and South Pole, and try to think about that diagram just now. And if I get this close to it, let's see what happens. How does the pattern look like? The one that I have normally is the red one, pointing to the north. I guess this is the north side. Do you know? Do you know actually our school, that side is north? Yeah? So the red one is actually pointing to the north, and that is to say the arrow we draw. The red one is an arrow we draw. So look at the red one. Are you okay with that? Just like how it's expressed. So that means to say the arrow should point to north or south. Actually, it should point to south. Do you see that? From the north side, it's actually pointing outward. Do you see it? Out is out. And while around the middle, how does the arrow look like?
Going out.
Around here. Which direction is it? Towards south as well, and this is not perpendicular, it's parallel to the magnet as well. Why is it parallel? Yeah, if you remember the field line that just now Sabrina drew on the board, that at this 2 points is more or less parallel, like the pattern just now you see, parallel to these magnets, right? And that's why it's parallel as well. And also you want to point to the south. That's why it looks like that. Okay, so remember this result. Can you remember this result? And now we are going back to your whiteboard and see which one is correct. Okay, let's go.